Yeah, guys, very good morning. Okay, the last class we discussed, rolling contact bearing. So still we have to go 1 hour, at least 1 hour to be required today and tomorrow, maybe tomorrow. Okay, will be completed this chapter. Okay, so today we discuss in the last class what we discussed. Static load carrying capacity and equivalent dynamic load carrying capacity. The static load carrying capacity, the guy who developed the concept, for finding the static load carrying capacity of the roller contact bearing. Sorry, ball bearing. Sorry, not roller contact bearing, ball bearing. It's a Strybacks equation, right? The Strybacks. Just 1 minute recap. The Strybacks equations we discussed this. Finally, we came to arrive that C naught is a notation of the static load carrying capacity of the ball bearing is K into D squared is into Z by 5. The Z is nothing but number of balls used in the bearing, in the bearing. Okay. Now, and then later we discuss equivalent dynamic load P, capital P is equal to X into Vf plus Y into Fa. In that X is X is nothing but our axial, radial load factor, and Y is nothing but axial load factor, and V is nothing but our race rotation factor. The V is 1 if we considered, when the inner when the inner race is rotating, outer race is fixed. When the inner race is rotating, outer race is fixed, V is equal to 1. When the outer race is rotating, inner race is fixed, then V is equal to 1.5. These are the things I put. We discussed in the last class. This V is equal to 1 and 2.2 dip. This theoretically we discussed. Now, theoretically we discussed. Now the load factors, radial load factor X and radial load factor X and axial load factor Y. Those things we are going to today discuss in the table. The manufacturer catalog we can get it these values X radial load factor, axial load factor and radial load factor. We are going to get it from the manufacturer catalog. But how to use these values we are going to discuss in the table, because already this the radial load factor, axial load factor, those things people gone through the practical conditions, then they defined that in the form of table. So that's what today we are going to discuss in more in detail. Now, load carrying capacity. Now, how we are going to define the life of the bearing, either in terms of millions of revolution or in terms of working hours. So those things we are going now. Yeah. Okay. Going to discuss today, because when we are designing the ball bearing, we need the radial load. Perhaps the ball bearing subjected to only radial load. Perhaps the ball bearing subjected to only axial load. Then, if the bearing is in identical condition, now we take two bearings, identical dimensions, then identical dimensions of the bearing, identical material. When the bearing 1 is only subjected to radial load, similarly the bearing only subjected to the bearing 2 is only subjected to axial load. But both the load, radial and axial, both are in same magnitude. Then then the low, I mean, then it will be a same life. It will be a same life. That assumption we are considered in the earlier for earlier discussion for finding the equivalent dynamic load carrying capacity. See here, the radial load in radial bearing, thrust load in thrust bearing, which applied the bearing would give same life when we consider the bearing 1 and 2. Bearing 1 is, for example, subjected into radial load. Bearing 2 is subjected to, I mean, axial load, but both bearings are identical dimensions and identical material. Then it should give the same life. Based on that assumption, we defined this radial equivalent radial load capacity P is equal to x Vf Vx into V into Fr plus Y into Fa. I mean, this assumption, this empirical relations, people might have been, the research might have been studied with the experimental analysis and the experimental and the numerical analysis. Finally, came to this concept for finding our equivalent dynamic load carrying capacity. I mean, dynamic load carrying capacity is different. Then how those things we are going to do. Equivalent. There are two notation. One is C. I mean, sorry, C naught. C naught. C naught is static load carrying capacity. P is dynamic load, equivalent dynamic load. P is okay. C naught is static load carrying capacity. Next we are going to discuss the C. This is the dynamic load carrying capacity. This is dynamic load carrying capacity. C naught is equivalent dynamic load carrying capacity of the bearing. Now we discuss, sorry, this is, sorry, extremely sorry, this is static load. Sorry, wrongly drawn. P is now P is equivalent dynamic load. Equivalent dynamic load. This is notation very important. C is nothing but our, I mean, dynamic load only. P is equivalent dynamic load. So then now we are going to discuss how to find out the dynamic load, because these are the parameters are important when we are going to design the bearing and when we are going to identify the bearing number because what is the bearing number we are going to discuss later. So as of now, these are the things we discussed. These are the parameters very important. I mean, what are the parameters important in the table? Based on these parameters only, we are going to access the our manufacturer catalog table. Okay. See, one is we need F naught, FA axial load, F for radial load, C naught static load, C dynamic load carrying capacity, P P is our P is our equivalent dynamic load. Equivalent dynamic load. These are the things. And the D, outer diameter of the bearing. Capital B, width of the bearing. Okay. And D, diameter of the shaft or inner diameter of the bearing. This is the things we discussed as of now, all the parameters we discussed, but this is the dynamic load carrying capacity we are going to discuss. And life of the bearing, I mean L base 10 life, this is referring that by bearing life in millions of revolution. This is refers that this is L based and refers that millions of revolution bearing life. L10H. L10H is refers that bearing life in working hours. Working hours. So these three things we are going to discuss, and these all the things we are going to use in the manufacturer table because manufacturer catalog they used all these values to define our bearing number finally. And I mean, some other things also we are going to discuss based on the, I mean, axial load to radial load ratio. Based on that also they defined that. We will see one by one. Just to keep in mind, just I have been, now I am telling that the outline of these things. Okay. And now before entering into this, I mean entering into the load drive relationship, now we should understand the dynamic load carrying capacity, how it is, how we are considering, I mean based on which parameter. See here, the life of the ball bearing limited by the fatigue failure. Okay, that's what, there are many, some more things, how I mean how we are considering the bearing life, those things we'll discuss point by point, then we go for this. The life of the ball bearing is limited by the fatigue failure at the surface of the ball and race. Okay. Now, the dynamic load carrying capacity of the ball bearing, the dynamic load carrying capacity of the bearing, now bearing is going to be considered, I mean, going to be found based on the fatigue life of the bearing. Okay. Now, the life of the individual ball bearing defined as the number of revolutions, number of revolutions, or number of working hours in service, number of working hours. Okay, at a given constant speed, at a given constant speed. That is important because we are going to discuss the table standard catalog book for car bearings life. What is the bearings life in the cars? What is the bearing life in the trucks? What is the bearing life in the heavy vehicles? Trucks also heavy vehicle. So we are going to discuss in different automobile vehicles and different machine tool, different machines, how much bearing, how much life of the ball bearing we are expecting, those things already based on the practical experience and practical study. They kept it as in the form of table. We are going to discuss later. Now just we have to understand the life of the individual ball bearing is defined the number of revolutions or in terms of working hours at a given constant speed. I mean, which the bearing runs before first evidence of the crack. Now, see here, what do you mean? What is the meaning of it? See, now you take a bearing. I mean, the bearing life you already predicted 100 millions of revolution. Okay. Now this now I'm telling that the bearing life is 100 millions of revolution. Now 100 millions of revolution, but the bearing at now we predicted 100 millions of revolution, but the bearing is at a practical condition. We are oftenly testing the bearing, right? When we are for application, when the bearings are in applications, we are doing testing. The testing, there are so many methods are there. I mean, a non-destructive method, X-ray method. I mean, X-ray also non-destructive method. There are different methods are that for testing the bearing, and I mean X-ray images, non-destructive method, in ultrasonics method, non-destructive method, under non-destructive method, X-ray and ultrasonics. Okay, thermography. There are different methods are there. Okay, we are testing the bearing while the bearing
Sir,
is working. Yeah.
sir, someone are still waiting, sir, for your permission to.
Oh, is it?
Yes, sir.
Yeah. Sorry. Okay. So, I mean, first we already predicted the ball bearing life is 100 millions of revolution. But when we are performing the testing using these methods, ultrasonic method or I mean thermographic or X-ray method, then we are identifying at 99 millionth of revolution, we are identifying the first crack on the bearing. First crack on the bearing, then that is the when first crack initiation, when the first crack initiation going to happen, then we have to consider that is the bearing life. That is the bearing life. Then 99 millions of revolution is the bearing life. Okay, so now I mean, then this is for this bearing. Suppose you are testing 100 bearings, Then we're testing 100 bearings. Then finally we are come to the conclusions. The life of the bearings, it's maybe all bearings or most of the bearings are 99 millions of revolution. Then we will come to the conclusion the bearing life in these dimensions, in these load conditions, the bearing life is going to be 99 millions of revolution. That kind of decision we should take. Okay, that's our first evidence of the fatigue crack of the balls. In the balls are raised. Okay, now hence, I mean, and the fatigue initiation itself we are identifying. Once we identify the first fatigue crack or initiation, we are telling that before that how much revolution the bearing is completed, that is life of the bearing. Okay, now the rating life of group of identical ball bearings is defined number of revolutions. 90% of the bearings will complete. I mean, what I'm telling here, I'm taking the 100 identical bearings. 100 identical bearings, most of the bearings, I mean 100 identical bearings is defined. For example, 100 identical bearings is defined the number of revolutions that 90 percentage of the bearing will complete. Okay, number of revolution whatever we expected. Okay, but they exceed before the first evidence of the crack. Okay. Now, the dynamic load carrying capacity of bearing is defined as the radial load and radial load of bearings or thrust load of the bearings. We already discussed this. Okay. Now, the minimum life of the bearing. Now, when the minimum life of the bearing is considered 1 millions of revolution. Okay. The minimum life in the definition is called here L base 10. L base 10 is nothing but millions of 1 millions of revolution. Okay, millions of revolution. I mean, which is 90% of the bearing will reach or exceed before the fatigue failure. Okay. Now the dynamic load carrying capacity based on the assumption of inner race is rotating and outer race is stationary. Outer is stationary or vice versa. Now I come to the load life relationship of the bearing. Now see here, this is the the relationship between the dynamic load carrying capacity and the equivalent dynamic load, the ratio between the dynamic load carrying capacity, sorry, the relationship between the dynamic load carrying capacity and equivalent dynamic load is equivalent dynamic load that will define our, I mean, L base 10, our revolution of the ball bearing. Now, I mean, we are not going to discuss about this, how it became like that, because they might have been gone through research and finally they verified with the experiment. Then L base 10, then millions of revolution is equal to, I mean, the numerator is dynamic load carrying capacity. Then dynamic load carrying capacity is C and sorry, dynamic load carrying capacity C, the P is equivalent dynamic load. Then this is a small p is a constant. That small p is a constant. That in the power small p is a constant. That is the for different bearings that the constant going to be varying. That is nothing but empirical constant. The empirical constant they might have been studied through numericals, I mean modeling, and also may be studied in the through the experiment. Hence, the P is equal to 3 for ball bearing, P is equal to 10 by 3, small p is equal to 3 for ball bearing, small p is equal to 10 by 3 is for roller bearing. Okay, then substitute this equation, I mean at 15.6, then finally we are going to get this relation. I mean, this is the P is equal to, then this C is equal to our dynamic load carrying capacity. P is we know already equivalent dynamic load. We already discussed this equation. Now C is equal to P into L by 10 power whole power 1 by 3. This is for ball bearing. This is for ball bearing. But L by 10 is, this is we have to we have to know that how much revolution our bearing, how much revolution required while designing the bearing, we should decide. We should decide. Okay, because any one component, if you are making or if you are designing, you should know the life at least, right? Yes, this component I would like to use 1 year or 2 years, such a way that similarly now we are considering, yeah, whatever bearing I would like to go for 10,000, I mean 100 millions of revolution or 50 millions of revolution. That thing you should define yourself. Then L based and P we already discussed. So L based also in that way only we have to define. Okay. Then these two parameters, if we know, then we able to find out our load carrying capacity. Then this is for the roller bearing. I mean, roller bearing, we used the small piece 10 by 3 relation. Okay. So this is, please remember this form relation, I mean, empirical relations, these two formulas. Okay. Now, now I come to this. Now, as of now, we discussed that L based and this is the ball bearing life in terms of millions of revolution. Now we come to the discuss the we are going to discuss the bearing life in working hours. Bearing life in working hours. Now, very simple. This is the, I mean, if you know the bearing speed multiplied with the our revolution, going to be finally we are going to be get into the, in the form of working hours. I mean, this 60 by 10 power 6, it's like assumed we are putting the here we are putting here for finding our bearing life in terms of working hours. Okay, these two parameter doesn't matter 6 by 6 10 per 6, but only n is nothing but bearing speed, right? Revolution per minute. Here this is millions of revolution per minute. Then we able to easily find out the bearing life in terms of working hours. Okay, 60 into n into L base 10 h into 10 divided by 10 per 6. Then we would like to find out from this equation. This is very easy equation, you can understand. Okay, already given millions of revolution, the bearing life in millions of revolution. Now we would like to convert in terms of the working hours, that's all. Okay, now when we are considering millions of the working the bearing life in working hours, I am using different notation L base 10 h. Now this is millions, I mean working hours, bearing life in working hours. Then from this relation, we are able to find out bearing life in working hours. Now this is the, okay, now to come to this, now whatever we discussed, some brief conclusion, then we go for the problem. Then C naught is the static load carrying capacity. This is the equivalent dynamic load. Okay, this is the, I mean, road life relationship of the ball bearing. L base 10 is equal to C by P whole power P. From this relation, we are going to find out the dynamic load carrying capacity. Then calculate the dynamic load and equivalent radial load. Call the dynamic load. Okay. The first test we are finding the bearing revolution. I mean life in revolution. Second step we are finding the dynamic load carrying capacity from this relation. Okay. Suppose based on the bearing type, suppose ball bearing, we are going to use these relations. This is a common relation for ball bearing. P is small p is going to be 1 by 3, and roller bearing small p is going to be 0.3. These relations we are going to use to define our dynamic load carrying capacity of the ball bearing for mean for that ball bearing or else roller bearing. Now this is the selection of bearing, I mean radial force, axial forces. This is FA and this is I mean FA and FR going to be defined. Okay, because the selection of bearings we are going to discuss later the bearing number based on the bearing series. What is the bearing series? I will tell you later. These are the information required. That's what we are telling here. Selection of the bearings. Now here dynamic load capacities when P is equal to FR1. P is equal to FR1. In this case, the bearing only subjected to radial load because P2 is equal to FR2. In this bearing, I mean the bearing subjected to only radial load. How here FR1, FR2? See here, for example, see here this system. The bearing 1 is here, bearing 2 is here. Okay. I mean, this is the bearing. I mean, here the bearing 1 and 2 located joined to the shaft. The shaft is again connected to the gears and again connected to the pulley. Okay. Now these are this distance where the bearings are located along the shaft, and these are the I mean the where the I mean gears and pulleys are located in the shaft distance already given. Okay, now here I mean the bearings, now here the ball bearing, here this is acting as a support as well as to allow the free rotation of the shaft. Okay, free rotation of the shaft. Now, I mean, see here the component, two components are there. One is gear, and another one is the, I mean, pulley. These are the power transmission component. Then, based on that, based on this component, we are telling that P1 and P2. Okay. Now, the both component only acting radial load. Hence, we are considering P1 is equal to F1. Hence, we are P2 is equal to FR2. Okay, now this is the based on this. Now this is the component. I mean, there are two components. One is gear and one is pulley. Here we are used for transmitting the power. Hence, based on this dynamic load, then we would like to find out the dynamic load carrying capacity based on P1 and based on P2. Then we are using here. Okay, but L base 10 is same because these two bearings must be identical. These two bearings must be identical. We cannot use different bearings because okay. Hence, L base 10 is same. Only the P1, P2 is different. Okay. Now I come to this very simple problem. Then we go to this how to use this manufacturer catalog book, manufacturer catalog table. Those things we discussed. First, we discuss this problem. Now see here, this is a problem in particular. Yeah, Kalyan, how many students are there? Hello,
Okay. Around 50, sir.
60. Please ask the student join. Today I am going to download this attendance from the WebEx, and every class today attendance will be shown to you in the tomorrow class, because after your CRC meeting head suggested that you have to take attendance mandatory like that. It's somewhere they are going to be considered the attendance. Okay, please attend the class. I put a message to ask them to attend the class, please. This
Yes.
class attendance I am going to show you in the next class. Okay. Yeah. See here the problem. For the first problem in particular application, the radial load acting on a ball bearing, radial load 5 kilonewton, and the expected life for 90% of the bearing is 8,000 hours, 8,000 working hours. Calculate the dynamic load carrying capacity of the bearing when the shaft is rotates at 1450 rpm. I mean, this is simple question. This type of questions you may expect. I mean, in gate exam or some, I mean, some DS. Actually, some public sector exams you may get it. This type of simple questions. See here the radial load given, bearing working hours given, L based and H given, bearing speed is given. Okay. Now we would like to find out the dynamic load carrying capacity, our C. What is C value? Now, I mean, when we are going for finding C value, the C formula we already discussed, P into L base 10. L base 10, this is a millions of revolution. Then whatever given here, this is a working hours, we would like to convert into millions of revolution. Now substitute this formula L base 10, then finally we are getting millions of revolution. Then we know that the bearing is only subjected to radial load. Then our equivalent dynamic load is going to be Fr is equal to 5000 Newton. Finally, substitute the formula whatever we discussed in the early slide. In C is equal to dynamic load carrying capacity, then P into L based on whole power 1 by 3, because this is a ball bearing, not roller bearing. Okay, suppose roller bearing means it should come 0.3. The power should come 0.3. Now this is the value. I mean our dynamic load carrying capacity value of the ball bearing. Okay, this is the problem. This also the same problem. Only we would like to find out here load, how much load is acting. Here the here this is a given. I mean we have to find out what is the, okay, anyway, the taper roller bearing has a dynamic load carrying capacity. Here the dynamic load carrying capacity C is given. Okay, and the desired life of the ball bearing, 90% of the bearing is 8,000 hours and the speed is 3,300 rpm. Calculate the equivalent radial load. I mean here they have given PC value. Now we would like to find out how much load is acting on the bearing. How much load is acting on the bearing? I mean that's what our aim here. Okay, how much acting, either the radial load, how much radial load acting on the bearing, we would like to find out. Now load is given, dynamic load is given, dynamic load carrying capacity given, bearing working was given, speed given. Then from this relation we are able to find out L based and bearing life in millions of revolution, in terms of millions of revolution. Then we know this equivalent, we would like to find out this first here. C is equal to P into L based on whole power 3. From this relation we have found that our equivalent dynamic load, but equivalent dynamic load, we already did. Equivalent dynamic load is nothing but F into X plus Y into FA. Here only radial load, then this is neglected. Finally P is equal to X into FR. Now X is equal to here assumed to be 1. Okay, because the outer ring is fixed, the outer race is fixed. Okay, now find this. From this relation we have found P. Once we have found P, we came to know that FR, radial load, is not, the P is nothing but radial load of the bearing. Now 5854.16 Newton. Now come to this. Now we come to this.
Excuse me, sir.
Yes.
So one doubt in the previous problem.
Previous problem we are finding.
In that X is the radial thrust factor, no sir. I mean radial factor, no sir.
X is the radial load factor. Yeah.
How do we, I mean, like get to know X equal to 1? Because we have decided as 1 because inner race is rotating and outer race is stationary, no sir.
We assumed it X is equal to 1.
Okay.
See here.
Okay, sir.
Yeah, you are correct question, because in the problem they didn't give that either X is equal to 1 or the outer race is fixed or inner race is fixed. They didn't give. That is your question, right?
Yes sir. How did we get the value of X?
Yeah. Here that's it. The X we are assuming here, the inner race is rotating, outer race is fixed like that.
Okay, sir. Okay.
Okay.
Yes, sir. Understood.
Yeah. Even though, I mean, they might have been given here. Suppose, I agree, it's a very good question. They didn't give here. If suppose they're given the speed of the shaft, then during that time X is equal to 1 or X is equal to 1.2. Yeah, please tell me, please. In this case, during the now suppose now I am introducing speed of the shaft is 300 rpm. Now X is equal to 1 or X is equal to 1.2. Now in this case, 1 or shaft is rotating. Then now inner race is fixed or outer race is fixed now?
Outer race is fixed.
Yeah. So actually they didn't give. I agree. Hence you can assume that X is equal to 1. Okay.
Okay, sir. Okay, sir. Thank you.
Suppose shaft is given, very clear. Your doubt is, I mean, you don't have any doubt. So now they didn't give anything there. Only the bearing is rotating. Maybe whatever you are saying is correct. The inner race may be fixed, outer race may be rotation. We do not know that, but perhaps soft speed is given much better. 100% we can ensure that one. No need assumption. Now we assume that x is equal to 1. Okay, anyway. Now come to this. Now we are going to see more information about now selection of bearing life. Now in the selection of bearing life, we are going to, because selection of the bearing life. In the selection of the bearing life, we are going to, this is a manufacturer catalog. Okay. Now we have to find out the expected life of the bearing. Expected life of the bearing when the bearing, when the bearing, uh, when selecting the bearing or designing the bearing, right? Now, based on the practical application, I mean, now what we are going to now we are discussing about the selection of bearing life. In this bearing life selection, we should have to, I mean, we have to find expected life of bearing when designing or selecting the bearing. Based selecting the bearing. Now, these are the things based on the practical experience they define. Based on the practical experience, they defined this for, I mean, automobile vehicles. See here, in automobile vehicles, the speed, for example, all, if you consider any vehicle, there each vehicle going to have different speed of rotation. Each vehicle going to have different speed. For example, you are in heavy vehicles, for example, bus, it may go maximum speed 100 kilometer per hour. If your two-wheeler is going to have more speed, right? So it depends upon the speed, right? Each vehicle going to have different speed, not a constant, right? Then they defined, and also based on the load condition. Okay, so they might have been gone through, they gone through the practical experience. They defined this for automobile cars. The life of the bearing is 15 millions of revolution. For trucks, 100 millions revolution. For trolley cars, 500 millions of revolution. Railroad cars, 1000 millions revolution. Sir, you may ask here question. Sir, this is a trucks and trolley cars, railroad cars are more heavier, but how the life of bearing is 1500 and 100. But see here, the automobile cars, we are using small size of bearings as compared to trucks, trolleys, and railroads. When the size is going to be increased, we do not know what type of material they are using. Okay, then based on the size of the bearing, based on the material of the bearing, also they might have been gone through that. Then they defined that. Now this now based on this, I mean, this bearing life based on the wheel application, the first table number 15.1. Now, suppose in our problem we are asking that automobile vehicles, for example, we are asking that some cars in the problem, then that the bearing life we should consider L based, and we should consider 15 millions of revolution. When we are saying that the components, the bearing components from railroad cars, during that time you have to consider this. I mean, L base 10 is going to be 10,000 millions of revolution. Okay. Now in other applications, now we move to some other applications. For example, okay, this is very important. For other example, the speed of the rotation is relatively constant and desired life in terms of hours of service. See here, now the recommended bearing life in this application, millions of the machines. This is the bearing life is for industrial applications. The machines used intermittently, such as the lifting tackle. This is a constant speed. Almost we are using same speed. For example, lift. Once the lift speed is fixed, the same speed we are following, right? We are not changing the lift speed mostly. Similarly, some operations in the industry, the machines, some of the standard operations in the machines from the industries, they are maintaining constant speed, right? And this, that's what we are saying, that relatively constant speed, in some machines in industrial application for lifting, for in the lift. Okay, lift we are maintaining the constant speed almost, almost we are maintaining the constant speed. And hand tool and household application, these are we are maintaining the constant speed, right? For example, wet grinder, right? I mean, we are using wet grinder for making I mean, we using wet grinder for different applications in our domestic application, right? For making food, right? In the wet grinder, the speed of the motor constant. Suppose I'm buying 1 HP wet grinder, the motor. You also bought it same speed. This is not always available 1.5 HP, 1.2 HP, 2 HP, not like that, right? Hence, in these places, we are managing the constant speed. Hence, in these places, we are considering the bearing life is 4,000 to 8,000 hours. Here also some flexible will be there, fluctuation, because I mean, when we are lifting when the lift, you may be in your home, if you are using the lift, you are always maintaining 2 people in the lift. Suppose in my home I am using the lift, I may be going 4 people or 5 people always. Then your lift life is going to be better, right, than compared to my lift, right? But then the bearing life also simultaneously, you are accessing your lift with less load, but I am accessing my lift load is more load. Based on that, we are saying this range, the bearing life 4,000 hours to 8,000 hours. Okay, now they come to this machines used in 8 hours in the industry per day. I mean, as electric motors and gear drives, this is 12,000 to 20,000 hours. Machines used in continuous operation 24 hours per day. We are telling that we are, the tab now we are using this value 40,000 to 60,000 hours. So this range we are defining for based on our load condition, based on other factors. Okay, so that's what we are telling the range here. Now I come to this gear drives, and the next one is values of load factor. Values of load factor. Now load factor, I mean, the which forces are acting on the bearing calculator. Now I take my point. Now, which load factors are acting, which forces are acting on the bearing are calculated by considering the equilibrium forces in vertical and horizontal planes. Now the load factors are used application involving gears and belt drives and chain drives, right? In the chain drives, now see here, for example, in gear drives, the gear drives, the load of gear drives is an additional dynamic load due to increase in the due to inaccuracy of the tooth profile and elastic deformation of the gear tooth. Based on that, we are defining this load factor 1.2 to 1.4. I mean, in gear drives, wherever we are using, where we are using rotating machines free from the impact, like electric motors and turbo compressors. Somewhere in the problem, if you consider, if we are asking turbo compressor or like electric motors in gear drive connected, then you have to consider load factor 1.2 to 1.4. I mean, these are the things, a practical condition they defined 1.2 to 1.4. Okay, whatever. Now reciprocity machine, now 1.4 to 1.7. Now belt drives and the chain drives. Now in belt drive, chain drives, dynamic load due to vibration. This is varying the load factor, because when we consider in the equivalent dynamic load P is equal to XCFR plus YFA. During that time, we didn't consider the other factors, vibration, impact, effect. Okay, those things we didn't consider. Okay, Hence, when we are considering those are the information, those are the parameters, for example, due to dynamic load, then the vehicle subjected into more vibration, and depends on vibration, they are defining this load factor. V belt, they are considering the load factor up to 2, and single ply belt 3. Because when we go for more load factor, you are designing the safe bearing. When we are going for less, because we are designing safe bearing, when we are going for the more load factor, it looks like a factor of safety only. When you are giving more, factor of safety is high, F is value high, your design is safe condition. Similarly, we are applying more load factor. So with some unknown parameters we are not accounted in our design. Hence, we are using this load factor based on these values. I mean, these values people gone through experimental studies. Based on that, they defined this 2 to 1.5 for belt drive and chain drives. Now I come to this now. I mean, we already discussed where I mean where that F axial load and radial load fact ratio we are going to use to define our bearing. Okay. Now see here, I already told you that in the early F naught by C naught ratio is 0.025. Now E value, E is nothing but, please, this is slightly confusing. If you understand, it doesn't matter. Very simple only. FA by FR is equal to, assume to be E. When FA by FR is going to be the ratio going to be 0.22, but the same time FA by C naught value going to be 0.25, then we can consider our load factor. During that condition, we can consider our load factor this one. Okay, I mean F A x is equal to radial load factor is equal to 1, axial load factor going to be 0. Now it is not necessary the E value. This is FA by FR is not the whatever the defined value now equal. Not necessary to equal when we are designing the bearing. Suppose my now I am designing another bearing. Now I am going to design the another bearing. The bearing load carrying capacity now, sorry, now the bearing whatever I am going to, this is a bearing 1. Now I am going to do second bearing design. During that time my FA by FR value is greater than already 10 the defined table value 0.22. Now my the G value here FA by FR is greater than, now my ratio, the second bearing ratio, my FA by FR ratio is now 0.23. Then during that time I have to consider this value, XY value, radial load factor, axial load factor. Okay. Now I'm going to do the third bearing design. During third bearing design, my practical, my practical FA by FR value going to be 0.18. 0.18. Now already the manufacturer catalog they have given 0.22. Already the manufacturer catalog they have given 0.22. Now my defined value is less than the 0.22. I mean during that time I have to take, again I have to take this value only. Very important. Okay. This is the value given from manufacturer catalog. Now you have to identify either our FA value, FA by FR ratio is less than equal to given manufacturer value, manufacturer catalog, or greater than the given manufacturer catalog value. Based on that only you have to define your load factors. Now this is the steps to be followed, and we finish it today theory. Please cooperate. Just to 10. How much? What is the time now, please?
26, sir.
Eh?
Still 4 minutes there.
Okay.
3 minutes.
Okay, please, we complete the theory. Tomorrow we complete the problem. Okay, please cooperate. I may take maximum extra 5 minutes, maximum 5 minutes only. The base is the selection of bearing from the manufacturer catalog book. First, you see here the basic procedure of the selection of the bearings. We should follow these steps while designing the bearing. While we are going to discuss in the problem, calculate the radial and axial force acting on the bearing. Okay, now this is the first we have to find out this force. Now, if we know this force only, we are able to find out our diameter of the shaft. If we know the diameter of the shaft, we know the inner diameter of the bearing. Inner diameter of the bearing. Okay, because those information required. I tell you in the next table. Okay, the second step, I mean, select the type of bearing. Okay, for given application, and determine the values of x and y, radial factor and axial factor from the table. Okay, from the manufacturer catalog, and now the values of x and y factors are single road deep groove ball bearing. Whatever we discussed from the table, this is given for single road deep groove ball bearings, not double road deep groove ball bearing. Okay, this is only for single groove deep groove ball, single road deep groove ball bearing. Okay, the values depends upon the ratios f by fa by f or fa by c naught. This is already discussed. Okay, now this is c naught is, I mean, static load capacity. Now, these are the things going to be done by trial and error. Whatever we discuss, we have to find out. Suppose, I mean, x e is equal e value less than or greater than or equal. Okay. Now, come to this next table. We are going to discuss about the, I mean, the single road ball bearing, the static and dynamic load carrying capacities of single row deep groove ball bearing, different series. What are the different series? Now we are going to discuss in the next. Okay, that now the next table they are given. See, for example, to begin with the bearing of light series such as 60, please keep in mind just 60 is selected for the given diameter of the shaft, and the given value of C naught is found from the table. Okay, I tell you what is 60 and how to define the series bearing number. Those things we will discuss in the upcoming slides. Okay, I mean, this is the bearing factor, the load factor. It can be founded from the earlier tables and this table. Okay, and we know that, I mean, life of the bearing also we able to find out from the earlier table based on the application of the bearing. Okay, from the earlier table. Now this is the, that's what we discussed, L based on in millions of revolutions. Once we have found these two, these things, we can easily found that our dynamic load carrying capacity. Now dynamic load carrying capacity, then later we have to define the bearing series. Bearing series means we have to define the bearing number. Now how to define the bearing number, we'll see here. Now see here, before entering that, just see the table. This is nothing but our diameter of the inner diameter of the bearing or shaft diameter. Now this is nothing but our outer diameter of the bearing, capital D. This is nothing but our bearing width of the bearing. Okay, so now this is the load. If the load is acting in my bearing diameter is, sorry, my inner diameter of the bearing or shaft diameter is at 10 mm. The bearing is subjected to, I mean, dynamic load carrying capacity 8006 Newton and static load carrying capacity 3750 Newton. During that time, my bearing number is 6300. 6300. Now I come to this. This is the bearing designation. Whatever we are discussing here, the dimensions and the static load capacities based on that dimension of the bearings and dimension of the bearings, static load capacity and dynamic load capacity. Based on that, we are defining the bearing designation. Okay, we are going to find out these parameters. This parameter. Finally, we came to know this one. Okay, now, I mean, I mean, even sometime we are going to concentrate, this one and these two. If you know these values, we can easily identify this diameter of the bearing, outer diameter and width of the bearing easily. Okay. Okay, we'll see the problem. Once we go to the problem, you can easily understand. So no, don't worry. Now we see this, then we close the meeting today. Okay. Now see here, the first thing, what is the, while selecting the ball bearing from the manufacturer catalog, we should follow the, we should mean very often terms the series, how to define the bearing series. Now we are going to discuss that. Now the all the rolling contact bearings usually designed by 3 or 4 digits. Now this 3 or 4 digits, what it is, that's what we are going to discuss now. Now this is the, okay, so now first you see here, the last 2 digits indicates the bore diameter of the bearing. Now, I mean, last 2 digits indicates for bore diameter of the bearing. Please assume that initially I am putting the 4 digit because the bearing destination going to be a 3 digit or 4 digit. In the 3 digit or 4 digit bearing destination, initially I am considering X, 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 X. But as per the manufacturer, as per the design data book consideration, the last 2 digit going to be our bearing diameter. That's what bore diameter of the bearing. That is divided by 5. That is divided by 5. Now these two parameters. Now I am putting, for example, I am putting 0.8. Now my bearing bore diameter is inner diameter is 40 mm. Now here 7 is 35 mm. Okay. Now I come to the third digit from the right hand side. Now this X. Now this is defines that my bearing series. I mean extra light series. If my bearing is extra light series, okay, extra light series, medium series, heavy series, depends on load condition. Now suppose my bearing is heavy series. Yes, I already told you that. Please cooperate. Just 5 minutes. I finish it today. Okay. Hello. Tell me, Bob. Yes, yes, I completed. Anyway, 10 o'clock you are going to a class. I complete within 5 minutes because tomorrow we will discuss the problem. It won't take more than 2 to 3 minutes, more than 4 minutes. Okay. Now the bearing series I put here 3 or 2, whatever. Now this is light series. It can be this bearing going to be applicable only light series, light load. Now this is going to be see that now for example X307 here given. Okay. Now the last one, the fourth digit defines that sometimes it will become a fifth digit also. Right, specify the type of bearing, either rolling contact bearing or I mean, for rolling contact bearing, the design data book they consider the standard. We are following the standard. Put a 6. If you put a 6, now this is if I say this manufacturer to this number. Now what is meaning? Our bore diameter is 40 mm. This is it defines my load capacity light series of the bearing. This is defines the 6 is defines that our rolling contact bearing. Okay, see here they're clearly given the in your book. Please go through that, you can get it. Light series bearings permit smallest bearing width and outer smallest bearing width. This light series also smallest bearing width. Outer diameter for given bore diameter, the lowest load carrying capacity in the light series. Medium series 30 to 40% higher dynamic load carrying capacity compared to the light series bearings. Okay, medium series. Now, however, occupy more radial space. Now, when we are going for medium series, the size of the bearings also little higher. Bigger size as compared to light series. Similarly, going to the heavy series bearing it will be more than 20 to 30% of the dynamic load carrying capacity as compared to medium series bearing. And when we are going for heavy series, the bearing size also going to be high. The width of the bearing also going to be high, and the diameter of the bearing is also going to be high. Now, see here, now, I mean, some of the figures we'll see then I close the meeting. Okay, this is, okay, now I come to this, how we are defining here. Now, I mean, the dimensions of dimension series, small, please, 1 minute. This is, okay, completed, no problem. Now I come to this, I mean, the ISO plan for the dimension series of the bearing is here illustrated in figures 15.7a. This is A, right? Now it consists of 2-digit numbers. The first digit number, see here, this 0, this is 1, this is 2, this is 3, right? Please carefully listen here. I erase this. Because, oh my god, the first 0, the first digit 1, second digit, first digit 2, first digit 3 defines here 0, 1, 2, 3 with the series of the bearing. I mean, with the series of the bearing. Now I come to this, I mean, the diameter of the diameter series. Obviously, the width of the bearings 0, 1, 2, 3. When the width of the bearings increases, when the series is increases. Width of the bearing is increases when the series number increases. Now, this is 0. Vertical axis is our diameter series. In the diameter series, we are taking this second digit of this two number. See, this is 0, 2, 3. Okay, 0, 2, 3. Now, diameter of the bearing. Now, here in width series 1, the diameter 0, 2, 3. Now, in this case, the diameters are same because see here, this 0, 0, 0, 0. But you see here, this diameter 2, 2, 2, 2. While considering in the vertical axis diameter series. Now I'm taking third as in the width series 0, width series 1, but now the diameter I'm considering both series same. Both series same. This is 3, 3, 3, 3. Okay, now when the now this is referring that is, please now you go through this information, you can get it. The first series indicate the width series. I mean, there is 8 width series. Now only we are seeing 3 only. You can extend further. Okay, 1, 2, 3, 4, 5 in order increasing the width. The second series, second number indicates the diameter series. Whatever you discuss, 0, 2, 3 indicates the diameter series. Now there is, I mean, diameter series in 4. I mean, and in 4 order of ascending. It is always the 4 order of ascending. Now ascending the outer diameter of the bearing. See here, now I come to this, see here. This is the light series bearing now. Because small bearing, the diameter is small. That's what we are saying, it is increasing. Okay, see here, the second number 0, 2, 3, 4. The diameter is getting increased. Now the diameter, but inner diameter is same. But this bearing, the same inner diameter, we can go for lightweight. But if you go for this bearing, the same inner diameter, we can go for heavyweight, heavy series, but the bearing dimension is more. So based on that, we are going to discuss these later classes, how to define bearing series or how to designate the bearing number. We are going to discuss in the later problem. Yeah, just yeah, very simple problem. I complete here this slide. The single row deep groove ball bearing is subjected to pure radial force 3 kilonewton from the shaft rotates 6000 rpm. Because once we discuss the concept, at least one problem we discuss, immediately you can understand. That's what, just 1 or 2 minutes on it take. I will complete here. I will stop it here within 2 minutes. The expected life of the ball bearing, here given the ball bearing working hours is 30,000 hours. the minimum acceptable diameter of the shaft is 40 mm. This means that our inner diameter of the bearing. Select the suitable bearing for this application. Now the radial load is given 3 Newton, 3 kilonewton, pure radial load, and bearing working hours given 30,000 hours. The speed of the bearing is given. Now from this we able to find out, from these two relations we able to find out the bearing in terms of millions of revolution. Now from this we are finding the in terms of millions of revolution. Now once we know millions of revolution, we can find out the dynamic load capacity. But here this is a pure radial load 3 kilonewton, then P into C is equal to P into L based on whole power 1 by 3. From this relation we can find out our dynamic load carrying capacity C. Okay, pure radial load here Fr is equal to P. Now, so then now how to select the bearing? Now our radial load, the dynamic load carrying capacity is 30,779 Newton. Now come to the table. Now this is our diameter, inner diameter of the bearing, inner raised diameter of the bearing, okay, or shaft diameter 40 mm. Now whatever we defined the load, see here, where is our C here? Where is our C is playing? See, C is playing 30,700 Newton here. Then now C is playing. Now see here. Now our C naught. What is our C naught now? You no need to go for calculation. Directly you can say that 16,600 Newton from the table. You don't need to go for calculation. Directly you can say that. C naught, how do we find? C naught is, suppose C naught is not given, we can use our Strybacks equation. You able to find out C naught. But now you don't need to go for C naught finding. C naught we can take it from the table. Now what is the bearing series? Bearing destination. Now this is the bearing destination, also satisfying our bearing diameter, inner diameter. Now this is 0.08 referring our bearing diameter. The 0.8 multiplied by 5, it will be given our bearing diameter, inner diameter. This is a 40 mm. Now satisfying with our bearing diameter, inner diameter. Okay, so now 2 is referring that our light series, medium series or light series. I think okay, it's a light series. I mean, it's referring that light series. The 6 referring that our we are in rolling contact bearing. 6 referring that rolling contact bearing. Now this is the, now what is the bearing width here? We know this value. We have found this value. Based on that, we have found that our C naught value. Based on that, we have designated our bearing number. Now later we came to know that our bearing outer diameter 80 mm and bearing width is 18. So like this we have to use this manufacturer catalog. This is the manufacturer catalog, or else you may consider design data book, design data table. Okay, so this way we have to consider, we have to use to define our bearing, bearing destination, and to define our bearing dimensions. Thank you guys for your cooperation. Please, if you have any questions, please go ahead. I stop it here. Do you have doubts?
Sir, in LMS assignment 2 deadline is not updated. Sir.
Updated. Now you check it. Already updated, ba?
Oh no, sir.
Which assignment? The second assignment or first assignment?
Second assignment.
Updated. Morning I did it.
No, sir. It is showing still overdue.
1 minute. Okay, first, yeah. Guys, if you have any, okay, if I ask them, do you have any doubt, please?
No, sir.
No doubt.
Okay, I will share you this yesterday video. I think yesterday video posted or not, Kalyan? I forgot. I think so. Yesterday video posted or not?
Wait, so